This is a short video. It's a continuation of my previous video, which talked about using the transformation equations to calculate IU, IV, and IUV, the product of inertia, on a rotated set of axes. In that previous video, I used this worksheet and worked this S-shaped problem and worked through the procedure. And I'm going to show you how to do this in the Excel spreadsheet that's included. But before I do that, I want to mention that in the OneDrive folder and also on the website, there's a blank worksheet like this that I used. And so there's the open space on this worksheet. I give the transformation equations. And so you can print this worksheet and use it for any problem that you want to do a similar calculation. So those worksheets are there. The worksheets are also there as a Word file too. And so you can go in and edit it if you wish, or change the spacing or whatever you want. But now we want to go to share. So now we're going to Excel to work the same problem. So in that previous problem, IX was 15.7. So there's two tabs. There's a tabs for units of millimeters, and there's a tab for units of inches. This particular problem has units of inches to the fourth. And so you basically enter your IX, which is 15.7. Your IY, which is 1.04, 1.04. And IXY was 2.68, 2.68. And so basically, those are our starting values. And our goal was to calculate IU and IV at where theta is 15 degrees. So if you plug in 15 degrees here, enter, then you basically get I at 15 is 13.4, which is what we got. 90 degrees plus that, which was the I, Y prime, or you could call it I, V, U and V. You could call it I at 105. But the 90 degrees from the 15, the I is 13.8. I'm sorry, the I is 3.36. And the IXY in that coordinate system, I think we got 6, but this is 5.99 inches to the fourth. And so just plug in that 15 degrees and you get those numbers. Or if you want to put in 10 degrees, you can see what it is at 10 degrees. You can put it in at 20 degrees and see what you get at 20 degrees. And so whatever angle you put it, you're going to get a different set of these values. And down here, these are the basic calculations for Mohr's circle, which we're going to talk about here momentarily. It gives you I average, which is the center. It gives you the radius, which is 7.8. It gives you I max. It gives you I min. And it gives you the principal angle, which is the angle from the x-axis to the nearest principal, either I max or I min, that's the closest to the x-axis. And again, that theta p is minus 10 degrees. You can actually use, if you go to data, what if, goal seek, you can actually take goal seek. So we can use solver to find the angle at which Imax occurs. We have a formula for Imax, but we can use solver or goal seek. And so at Imax or Imin, the product of inertia is 0. So I can set this cell equal to 0 by changing the angle. And I basically get 80 degrees. So at 80 degrees from my x-axis, I get the minimum. I get 0.565 is my minimum. this side's 80 degrees. So if I go 10 degrees clockwise or negative 10 degrees, I should get the max. And so if I go negative 10, which is what it says here, this says negative 10 down here, I get the max. So, so these are ways you can use this sheet. The equations are all programmed in here. You can use this to help set up more circle. You can use this to check your answers. And again, like I showed you, there's worksheets available to you as well on the OneDrive or on the website. So these are tools that you can use.